So my name is Jakob Gärtner. I started the company Railergy about 8 years ago, and since before Railergy, I've always liked and loved and worked with DDS. And since Zenoh came up, we have started looking at that, and the last few projects we have really just started directly with Zenoh. So I want to tell a bit about those projects. So this is not a research experience, it's an industrial experience. So we have different applications that where we have used Zenoh, so have more the character for proof of concept. Some are intended as a platform for research, for other research projects, but we also have one project for now where to reach certification. That means that the train will be certified for operations in the real world at the end. So the first project was for a French company, Thales, but for their German subsidiary, they have a lab train, and this lab train needed a remote control. They wanted to show that because they were working on 5G communication, and for the demonstration that you can train from far, they had a remote control system from us, which we built in just 6 weeks. This, by the way, this first version of the remote control was still done with the MQTT, but now we have switched to Zenoh for various reasons that I explain later. There's another such vehicle from Deutsche Bahn where we also have a distributed system. You see that there are many different boxes inside. The gray one here is a safe computer that supervises the other. The orange is just an industrial programmable logic controller, and here I don't know if you see, that's a very high performance computer that has a GPU that can process perception data such as LiDAR or camera. We can also see that even the system is distributed. We have the vehicle that is being controlled by some digital in and analog in and outputs, and we have different computers that talk to each other. They all use Zenoh to exchange the information in real time, and also the gateway to the systems, especially to the land side of the remote control of automatic train operation management center, is also at least partly being through Zenoh, partly because for some of the protocols there is a standard that you have to follow, which is a point-to-point that goes over GSMR, so it's really a dial-up, and you don't even have TCP, IP, or any support, and you're not allowed to use any middleware. But for everything where it's allowed and where it's possible, we are using. Here's our flagship project at the moment. It's quite a complex project where those old locomotives have to be converted to become autonomous, and you see that there are many systems. We have a sensor package, we have an automatic train protection system, automatic train operation system, a positioning system, then what we call the perceptive engine, which really processes the stream from the different cameras and LiDAR sensors, and then has to decide if there's an obstacle truck and the train has to stop or not. You can also see that there are many components here. Basically, this is now all in German, but in the middle we have the track component. On the right side we have the onboard component. They talk to each other, and also for this communication between the control center and the different locomotives. They can be many locomotives. They can even be distributed across the whole country. We are also starting to use Zenoh also inside the system between the different subsystems. You can also see, I cannot explain all of this now here, but you see that the subsystems has again lots of subsystems, and we decided for redundancy, availability, but also for performance reasons that we want to have a loosely coupled system, in the sense that all the main functions are, even if they reside on the same computer, also again communicating as Zenoh. And this brings us to a hierarchy of routers that are running on each system. I have a picture of a system later where I can explain what is happening where. A remote control system is evolving to a line, because because this remote control technology will be a fallback solution in case an automatically operating train has to stop because the automation encounters a corner case that it doesn't know how to handle, or if the system failure, then so-called remote services have to take control of the different trains. And each remote center, you can imagine there are some loco drivers there that sit in front of cab simulations where they see all the information about the different trains. And once a train gets in a section, then it has to connect to the right center, and they are distributed because the locomotive drivers that sit there, they have to know the area, so they really have from the area. So there's kind of a roaming function that if a train moves along a track, it will be handled different such remote service centers. And you can imagine that the routing, if you try to do it traditionally, would be quite complex, or you have to have some centralized broker like you have with more traditional approach. And what we really like very much is that each RSC has their own route and Zenoh router. Each train has its own router or even several. And then this of discovery is doing the rest. We are very sure that we are out there. We don't have with topologies. I've seen presentations before, some interesting tools that we will probably want to have a look at. Use case where the routing is the challenge, and I don't really imagine how we could do it efficiently or as quickly and develop those in such a straightforward way if we would have to use some manual routing. And I imagine doing it with standard TCP/IP routing tables and so on. It would be a nightmare. The other use case is that this automatic shunting locomotive has LiDAR sensors. They stream point cloud data 600 megabits per second, which is a lot of data, and they have to be processed in real time. And the big problem is that just point-to-point transfer of data is not the problem. The problem is that we also need a pipeline, because on the locomotive we cannot have standard big servers with big GPUs. We need certifiable hardware, and this certifiable hardware is safety related, and the processors that are able to undergo certification without a big effort, they're usually not so powerful. And also we cannot use Python or any other such things that would help us. So we have to really distribute the task across different. It's a bit the same what we heard in some of the presentations before, where they had a fleet of Raspberry Pis, or where they had other distributed ways, like in ROS, where you can also distribute applications. So the LiDAR data, they stream through filtering, for example, where we just say we only need the data that are really above a truck, because we're not interested in data that are not related to obstacle. By definition, an obstacle is on the track. We have to do segmentation with different methods, and then in the end, we have to find the obstacle. We also have to record all the data. This is just one line here, but all the at least for 1 hour have to be recorded. So LiDAR data have to be recorded, and the backends have helped us very much in setting this up. Our hardware is typical 19-inch rack with 3 GPU modules. They're not very powerful, each of them, but what we are doing is that if we have an application that is needing a lot of compute power, we are kind of deploying it in a serial way. So the first step of the algorithm would run on the first computer, the second one on the second, and so on. But we are also doing it in parallel so that we have redundancy. And this flexibility to really have a system where even if failure of one of the redundant systems, we just take it out and we push another one in, and it continues to work. That is also something that was not really imaginable before. you remember, Angelo, you remember the work that was done by a student based on the technology at the time for developing these voting algorithms, but the system rebuild time with Zenoh is much faster than with DDS, so we switched also here on this low level. Then there's something interesting maybe for all of you. We are using this based software development process based on a tool called Skate, where we have graphical of the software, where we also have automatic code generator that is certified to generate code that then can be used in railways up to SIL 4, so to the highest safety level. And by the way, also building models of the distributed application model, so that we also always have the coherency, completeness, and consistency of the model. And then we take out sub-models, and for those we generate the code. We have built a tool that's not yet totally perfect, but it's working. We can, from the model, generate the code, but also code that then also uses Zenoh as a transport between the different units that we generate out of the same model. And the interesting thing is that we are mapping the Zenoh topics to variable names and types. This mapping is defined in a file. We are always sure that we know who talks to whom and who is allowed to talk to whom. So the topics are directly derived from the model. This is a bit a different level than the tool presented before, but it goes a bit in the same direction. That's it already.